Hello, welcome to Prepclass Tutors. I am Abel Godwin, and today we're going to be looking at some Waec mathematics past questions, year 2019. So this is going to be a continuation from our previous video, and our focus will be on question number 6 to question number 10 in this particular video. So I urge you to subscribe to our YouTube channel. Subscribe to give us that encouragement to keep this production going. So starting with the question ahead, question number 6. It says, if t is a prime number and m odd numbers are subset of integers within this range, that is x is greater than 0 but less than or equal to 10, and x is an integer. Now we are required to find t prime intercept m prime. What it means is that we need to know elements of t prime and also get element of m prime and look for what is common between the two. So let's see this. Now, t we were told are prime numbers between 1 to 10. So these are the only prime numbers between 1 to 10. M happens to be odd numbers between 1 to 10, and these are the only odd numbers between 1 to 10. Our universal set comprises of the numbers 1 to 10. Why? Because the x is greater than 0. So it's actually not supposed to be a member, the 0 here. So, but our emphasis is the t prime. This means numbers that are here that are not here. And as you can see, 1 is here, but it's not here. 4 is a member of the universal set, but it's not in this. 6, the same thing, is here, but it's not here. And 8 is a member of the universal set, but it's not a member of set T. And continuously in that manner, the same thing happens to M. As you can see, there's 2 here, there's no 2 here, there's 4 here, there's no 4 here. So everything even here would directly negate the odd numbers that comprise our set M. Now, we have these two sets as T prime and M prime. And our focus is to actually get an intercept between this. So what is common here and is also common here? There is 4 here, there is 4 here. And if you look at it, there is 4 here, there is 4 here, there's 6 here, there's 6 here, there's 8 here, there's 8 here, there's 10 here, and there's 10 here. So these will make up the intercept of T prime intercept N prime. And that is supported by option A. So proceeding to the next question, question number 7. It says evaluate logarithm of 9 to base 3 minus logarithm of 8 to base 2 divided by logarithm of 9 to base 3. A better version of this is written here. So this is what we are required to evaluate. And so it seems there are some typos in this question precisely. So you can neglect this and look at this. So this is our focus. We need to work on this to see what will be the equivalent of this. Now, you remember that our 9 is the same thing as 3 squared. And our 8 is the same thing as 2 raised to power 3. We're trying to rewrite everything here. Just this time around, trying to manipulate some or apply some use of indices here. Now, in a similar manner, this is also the same thing as log 3 squared to base 3. So as it is now, remember your power law from logarithm law. It says that whenever a number is raised to a power, we can use it to multiply the log. So that means this 2 here can leave this exponent position and come as coefficient, which is what happens here. Now, similar thing happens here too. The 3 can leave this exponent position and come to stand here as 3. And same thing here, these 2 can leave and come here to become a coefficient here as 2. So we now have 2 log 3 base 3 minus 3 log 2 base 2 all over 2 log 3 base 3. Now, you need to remember this, that the logarithm of a number to its own base is always equal to 1. In other words, if you have log 10 base 10, that's going to give us 1. If you have log 7 base 7, that is 1. Log 8 base 8, that is 1. So once the numbers here tally, the answer always will become 1. So this is why this is 1. And as you can see, this is also 1. As you can see, this is also 1. So this is 2 times 1 minus 3 times 1 all over 2 times 1. So this is 2 times minus 3 is going to give us minus 1, and then 2 times 1 is going to give us 2. So our final answer is minus 1 all over 2. This is option D. Question number 8 says, if 23y is equals to 1111 base 2, find the value of y. So here we go. Now we need to convert this and give it a common base, and using base 10 is one of the easier approach we can apply to this. So here now, converting this to base 10, we write the first number times the base raised to the power of, how many digits do we have here? 2. 2 minus 1 is 1. So the first power will be 1. And the power keep decreasing by 1 continually. So here we have 3 here. 3 times the y now is power 0, as you can see. So coming to the right hand side, the same strategy follows. We have 1 times the base here raised to the power of how many numbers? We have 4. 4 minus 1 is 3. So the first power of the base will be 3. Subsequently, the next number here is 1, and then we'll now say 1 times 2, which is the base, raised to the power of 2. As you can see, the power drops. It keeps dropping from 3 to 2 to 1 to 0, like that. And if we happen to have fractional powers, it will even go into the negatives, minus 1, minus 2, like that. So this is what we have at the right hand side, and this means 1 times 2 raised to the power 3, which is 8, 1 times 2 raised to the power 2, which is 4, 1 times 2, which is 2, 1 times 1, which is 1. Now, by the time we make additions of these, 8 plus 4 plus 2 plus 1, we're going to have 15, and we have 2y plus 3. Make 2y here the subject. This 3 will cross to the other side. We have 15 minus 3. This is equivalent to 12. Now, 2y is equivalent to 12, and we need to make y the subject of the formula. So what we need to do is to divide both sides by 2. And by so doing, the value of y is 6. So this is option C. Question number 9. It says, if 6p and 14 are consecutive terms in an arithmetic progression, AP, find the value of p. So we just need to remember this, that the common difference will have to be the same. If you're dealing with an AP, the common difference is always the same. So since this happens to be an AP, they form an AP, it means the difference between the second term and the first term, which is the common difference now, will be the same thing as the difference between the third term and the second term. So this is common difference. So that is why these are equal. So what we need to do now is just to solve for the value of p. P crossing to this other side, we have p plus p, minus 6 crossing to this other side, we have 14 plus 6. P plus p is 2p, 2p is equivalent to 20. Now we need to divide both sides by 2. 2 divided by 2, C2 cancel 2, 20 divided by 2, that is 10. This makes the value of our p to be equivalent to 10. So we have p to be 10. And this is supported by option B. Finally, we're going to the last video in this particular episode, and the question says, evaluate 2 root 28 minus 3 root 50 plus 72. So this short question, as you can see, this is it. We need to break this down to its simplified form before we can carry out the operation easily. 28 is the same thing as 4 times 7. Here, we strategically pick a perfect square such that we can easily solve or reduce this sort. So 4 times 7, and here we didn't just say 5 times 10, no. Strategically, we pick a number that's a perfect square. So here we have 25 times 2, And for this, we didn't just pick a number anyhow. No, we picked 36 times 2. So the aim is to make one a perfect square. The other can be anything like that in trying to reduce the complexity of the sort. So this can be broken according to the laws of sort. This is root 4 times root 7. So they just share this like the umbrella. Everybody takes their own share. So root 25 times root 2, root 36 times root 2, like that. So root 4 is 2, 2 times 2 is 4, so we have 4 root 7. Root 25 is 5, 5 times 3, we have minus 15. Root 36 is 6, so we have it here, and root 2. So as you can see here, this sort is a bit different from this. So we need to actually operate on these like terms and leave this alone. So I have 4 root 7 minus 15 root 2 plus 6 root 2. So this is just saying minus 15 plus 6, and that will give us minus 9. Then we'll put the unit of our root 2. So our final answer is going to give us 4 root 7 minus 9 root 2. And this, as you can see, is option C. So we have come to the end of the video, and please do well to join Prep Class on WhatsApp, because you can also directly ask questions there. You can ask questions about the classes. Maybe you have an encounter that you need clarity about. So until then, have a nice day.